So without no further ado, this is Mohit, the Kardashian of tech.
Thank you for that fabulous introduction. I never really thought in my entire lifetime that I would be compared to a Kardashian. So I'll take that as a compliment. I think this is like a right size of group to be talking to about this, because I want to keep this as interactive as possible. This is not a presentation. This is not like a talk where I'm just talking at you. I want to talk with you. And so if you have any questions, concerns, any tangential thing that comes to your mind and you want to talk about it, we can totally do that. The time does not suffice. As Mario said, we have a particle booth outside where I do have all the sculptures on display, so you can come and watch and ask questions. But yeah, so why are we here today? We are here to talk about, sorry, he gave an introduction, so I'll probably give my introduction again. I'm a full-time senior hardware engineer at Particle. How many of you know about Particle? Or have used the products? How many of you know about IoT? So at Particle what we do is we make hardware and software products for people to make internet-connected devices or products. So imagine the Nest thermostat in your house that learns from your behavior, or a jacuzzi. They're using our product in their bathtubs to understand if the water quality is good or bad, or if it needs a servicing, or you can remotely start warming up your jacuzzi on that fabulous day. So we make hardware and the software for this to happen. And at Particle, I am actually working on designing these. So if you have seen circuit boards, computers, the things that go inside computers, cameras, cell phones, the hardware that runs it is what we design. We also design accessories so that you can actually start using them in real products. So being able to control a pump or a light or measure temperature and stuff like that. So this is what I do, but this is not what we are here to talk about. We're here to talk about freeform circuit sculptures, which is almost the exact opposite of what I do for my day job, which is designing circuit boards. But this is the way I relax by making freeform sculptures as an artistic exploration into taking your day job and converting it into a hobby or an art form. So what is freeform soldering? How many of you know or have done soldering of some kind? How many of you would love to learn how to solder? You're at the right place. We have an Autodesk booth where they are actually teaching you how to solder and how to design PCBs. That you or your family can go there and actually build circuits. But what is freeform soldering? If you saw previously, all the circuit boards are, the electronics are made on this board. They call it the printed circuit board. It has tiny little copper traces that connect components to each other and does make them work. But freeform is where you don't use a circuit board and you just connect these components through wires. And then they're also called as dead bug soldering. Dead bug because if you look at this chip on the left, it's like a bug upside down with the legs sticking up. So it's dead. And so that's one way of assembling circuits. The other one is you basically use wires, a copper wire, brass wire to connect things together. Or you can use combination of circuit boards and components to make something that is freeform. But freeforming is not anything new. People have been doing freeforming, since ages. Even before electronics was born, people were connecting these things together with wires. And wires at that time didn't even have insulation on them. They were like bare conductors connecting each other. Or on the example on the left, you'll see they were called as tag boards, where people will connect these manually, these components. You're still soldering and wire. So freeform is nothing new. People have been doing it for a while. But we are here, but then you realize that why are we freeforming sculptures when there are circuit boards? What's the reason behind freeforming when you can design a circuit board cheaply and easily? There are multiple reasons. You can design a quick prototype using freeforming because you don't have to wait for a circuit board to be manufactured and you don't have to assemble it. You just do a quick prototype. Or you don't have access to a circuit board. Say you are a student at a university or a homemade maker out of your home who do not have access to circuit boards or don't want to use circuit boards, you can easily freeform these electronics. Or you need to keep things really, really small. And since you're almost soldering them to one another, you can really reduce the size and make them small. Or if you're debugging something, say not all things that you design are going to work in the first instance. So you need to debug something, mock up a circuit, and connect an IC to the circuit board and do that. But what I'm really interested in freeforming is as an art form. How can we design circuits that are pieces of art rather than just functional units? So I'm talking about sculptures like these, where you're using the same components that will go in your electronics, in your television, in your radio, and reimagining it to make sculptures. So instead of having these things inside an enclosure in a plastic box, we're talking about bringing them out, like really showing off what they are made of, and in a way that electronics is now really talking to you, because there's no barrier between the components and you. So that's what I got interested in. But how did I get into this? Have you heard of beam robotics? BEAM. Beam robotics is something. It's an acronym for biology, electronics, aesthetics, mechanics. The term was coined by a scientist named Mark Tilden, who's Canadian. He used to work at Los Alamos National Laboratories and went on to design toys in Hong Kong, but that's a long story. The idea being that you make these seemingly intelligent robots out of simple electronics. You're not programming them, you're not doing any software, you're using simple broken pieces of cassette players. I wonder how many of you know what cassette players are. Or Walkman players or Discman, basically reusing these electronics to make intelligent robots, or at least seemingly intelligent robots. So I read an article about Mark Tilden in Reader's Digest magazine as a kid growing up in Mumbai, India in 1998. And I'm like, wow, I really don't need to buy anything. I can just salvage old electronics and start building these robots. And so that was how I got into robotics and electronics in a way. But you'll see beam robots mostly powered by solar energy because then you don't have to use batteries. But they come in all shapes and sizes and forms. Most of them work with the principle of chasing light, because solar cells are their, you can call their mouth, and they're constantly chasing light to survive. But again, none of these use any special computers, and this is back in the 90s or early 2000s where people were building these, and somehow that has kind of vanished because chips have gotten so much cheaper to buy and use. The other hobby that I used to indulge in is ham radio. How many of you are ham operators here? Any? Oh, cool. At least one. So ham radio is again an amazing field to introduce yourself to the idea of electronics. Before the internet, people were using ham radios to talk to each other. And so you could be transmitting a signal all across the world and talking to people real time using the things that you made. And so I was always fascinated by this, and I started building. These are not my designs, but you can see how these one-off circuits are built out of in a free-form manner. And then there's this artist named Peter Vogel that I got fascinated by. He unfortunately passed away a few years ago. He was a German artist who would use electronics to make these sound sculptures. They were interactive, so you can use your shadow to make music. And he used the same philosophy of exposing these electric circuits and like using them as art form. But fast forward to 2015 is when this is how I actually got into the modern day freeforming. Is I was walking down an aisle of Ace Hardware. Do we have Ace Hardware in Florida? Yeah. They're everywhere, I suppose. But that was my first time, and I came across brass. And again, I have seen brass in brass sculptures, brass wires, but I have never seen brass rods. And somehow I put the two and two together, and I had this aha moment. What if I could use brass instead of copper, or brass instead of the wires to make these sculptures? And I went home, brought some brass, and I made my first sculpture which is also connected to the internet. Like a simple 7-segment display, some resistors and some brass wires, and I was able to make something that felt like it had like a face and a body. And this was picked up by Hackaday blog. Have you heard of Hackaday? Yeah. Hackaday.com. And they showed it, and people were like, this is interesting. I've seen this before, but this is a different take on freeform. So I was, kind of excited, and I designed a few more variations, primarily using brass again as a medium. But you can see they are kind of similar because they're using the particle photon, which is like similar to Arduino. You can write a program for it in C or C++ and actually have it talk to the internet and collect data remotely, control it remotely. But I was so fascinated by brass and just began using brass. But why brass? There are multiple reasons. Brass is extremely easy to solder because, like copper, it's an alloy, not like copper, it's an alloy made of copper and zinc, and so it's very conducive to solder. You can easily solder it, you can easily cut and bend it, but interestingly, it's stiffer than copper. The zinc in the alloy makes it stiffer, so when you have structures, they will hold their shape. It does not also tarnish as easily as copper, because I remember growing up in Mumbai, which is a coastal city just like Miami, and the coastal air really tarnishes your precious metal like gold, copper, but less so brass. Brass ages really well. It's also beautiful, it pairs well with wood, since the warmth of the brass really helps. I have also used copper, but only as interconnects and not for actual the structures. So you can buy brass rods or brass wire. I primarily use 0.8 millimeter rods. If you can't find rods, by the way, you can buy these at kasmetals.com or Ace Hardware or Blink, Micromark, McMaster and Carr sells these. They are widely available. But what I realized that they were widely available in the United States, but in not other countries. But brass wire is something that you can find more easily than brass rods. We will talk about how we can convert one of these into rods later in the presentation. But if you're interested or if you don't have access to brass rods, you can always buy brass wire. There are certain things that you should avoid, which is the dead soft, which is used in jewelry. And it's very malleable, very soft, so you probably would not want to use that. They call it half-hard brass wire. It's either yellow or red, depending upon the content of copper in it. All right, so enough about brass. How do we actually start making these sculptures? So today, my focus is to primarily talk about how I go about making these sculptures and why I make these sculptures and how you can get involved, and there is a community that you can access and learn from. So you don't need a hell lot to start making these. All you need is like a soldering iron, solder, flux. People don't use enough flux, I feel like. So flux, pliers, diagonal or flush cutters. As far as skills go, basic soldering, you don't need to be really, really good at soldering. Simple soldering techniques would work. Basic understanding of electronics, this is getting more and more easier thanks to the internet. There are a lot of YouTube videos, a lot of websites like SparkFun, Adafruit, Seed Studio, even Wikipedia that can teach you about basics of electronics. And then lots of patience. This is something that does not come naturally. I mean, it's a learned art form, but I think if you need to finish a sculpture, finish a circuit, being able to debug it, you need a lot of patience. Let's talk about what kind of soldering iron you need. I usually recommend 50 watts or higher, because anything lower than that will have trouble heating these brass sculptures with brass rods and keeping them at temperature. So 50 watts big minimum. I interestingly won this particular brand at a Make Magazine's online quiz, and this was like 6 years ago. So thank you, Make. And so I use Weller. Weller is a German company, make really good soldering stations. Another company is Hako, and they also make good soldering irons. Thing to note, buy something that has replaceable tips. Tips wear off very easily. And you invest in a brass wool. Brass wool is something that you can use to clean the tip of the soldering iron after every solder joint you make. Just keep this.
Why do you prefer brass wool over just the sponge?
Because this is not abrasive, and so it won't take the tiny chunks of burned flux from it. People are often don't even like using damp sponge because it creates this thermal stress, because the sponge is cold, your soldering tip is hot, and once you dip or try to clean it with like a wet sponge, you're creating a thermal shock on the tip of the soldering iron. But I personally prefer brass wool. It works well. You can also just use a damp sponge. But I think brass wool helps in keeping the tip really, really clean. Thank you for the first question. More questions. I appreciate questions. Second thing is solder. Nothing, no rocket science. You can use lead-free or leaded solder. I usually keep around a 0.4 mm and 0.8 millimeters. People are okay with metrics here, right? They're not all about inches. It's millimeters. Just to, if you are soldering something really, really minute or something big, usually you would not think about this, but a lot of times when you manufacture electronics, it can be literally washed, because there is a lot of flux residue, which is water soluble if you use this. And you can literally use your toothbrush and soap and water to just like scrub your electronics clean. And as long as you're drying it after that, you should be fine. Usually they ask you to use distilled water so that there are no salt residues on your electronics. But yeah, you can literally wash your electronics. Not that I recommend washing your iPhone. Flux. I like to use two types of flux. Flux in a pen form, where you can just apply flux to the joint wherever necessary. And these things last forever. Like I bought a pen like 6 years ago, and I've been making that, and it still isn't used. The other thing you can use is a flux. Yes.
Oh, sorry.
Yes.
You said whenever necessary. When is that? Because I don't know.
Yes.
Sometimes.
Very good question.
Repeat the question. I didn't hear the question.
Oh, the question was, when do you know if flux is necessary? And whenever you are soldering something, you have solder wire on one end and soldering iron on the other, and you're applying heat and solder at the same time. And that's when you don't need flux, because there's flux already in the solder wire. But if you're soldering something with one hand, because you're holding the sculpture with other, so you can apply flux, take some molten solder on your soldering tip, and then apply solder. And so the flux on the brass or the circuit helps the solder to flow properly. So it also makes this hissing sound with zzz. That's very pleasant. I don't know. But yes, this particular flux is made in Japan. It's not for circuit boards. It's mostly for interconnects, because otherwise the acid in it will eat away the circuit board. So you have to keep that in mind, what kind of flux you're using. But a water-soluble flux pen is probably all you need. The other thing I like to invest in are nose pliers. You can go to a jewelry shop like Michael's, and they have these pliers over there, like micro, just a flat tip pliers, and diagonal or flush cutters. The interesting thing about this particular brand of flush cutter is that it has a retainer tip. And we'll see in a few slides later, is when you clip something, nothing goes flying off. It retains the thing that you have cut in the cutter itself, which is very handy when you're cutting things and things go flying off. So Zuron is, I think, an American brand that makes these high quality pliers and cutters that you can invest in. Not very expensive. I think they're like $12 and $15. So better than going to, say, Home Depot and buying their big ones. So these are my favorite. So what does the process look like? This is, by the way, all you need to start actually making these freeform circuit sculptures. I usually start with sketching, just doodling on a piece of paper and understanding what I'm trying to create. Often the sketch and the real thing are completely different, but that's okay. At least you are able to think it out loud. Drawing a schematic, breadboarding, we'll see all of these steps. Making templates and jigs, cutting and bending, soldering, and then the cleanup. So let's see what my sketching looks like. I have a few of these sculptures at the booth that in real form, but I usually just, in the evenings, just like pen and paper and just like try to come up with as many ideas as possible to make sculptures. My book currently should keep me busy for the next 1 year because I have more sketches than sculptures. That's okay. So you should start with sketching. The next step is you do schematic layout. Now this is not absolutely necessary. If you know electronics, if you want to share what you're doing, then doing a schematic of the circuit helps. And this is as I said, not absolutely necessary. It can be on pen and paper. But being able to do this then allows you to say, like, hey, I made this sculpture and this is the schematic. And people who can read or understand schematic are like, oh, I see that, and go from there. The next step is breadboarding. How many of you have heard of breadboards? Not the ones in your kitchen. Oh. Breadboards are something that allow you to quickly prototype an electronic circuit. There's this plastic board with lots of holes in it. It looks something like this on the left. It looks like, ew, what is this, all this wiring mess? But it is important for you to be prototyping your circuits on a breadboard first, figure out which light am I going to use, which value of resistor I'm going to use, and just iron everything out before we can move on to a sculpture like the one on the right. Making templates. So you will see that when you bend things and you're trying to place things, put things together, you need some kind of a reference. And so templates like these, so for example, the thing that I had breadboarded in the previous slide is I would draw a schematic layout on a piece of paper and actually use that as a reference to bend the wires and place the components. And so all of this looks intricate when it's assembled, but on a basic level, these are all stages or sub-assemblies that you put together. So on the left, you'll see just a standard printer, print out the schematics, and we will talk about how we solder those together later. But yeah, 3 stages, and then you assemble them, stack them together, and they turn into sculptures. This particular sculpture is also available to see at the booth. It's basically just an LED chasing light. It doesn't have any software. It uses simple electronics that is taught probably in high school or first year of engineering. And so very easy. So yeah, making templates. There are other ways you can make templates. For example, these are again blinking lights. I'm using what is traditionally known as a PCB layout. So that thing would probably be placed on a circuit board instead of a sculpture. But I'm using that as a reference to make a sculpture. But this is, again, you'll see it's a 2-dimensional sculpture. There are no third dimension to it in a way where it's not 3D. This is the most intricate sculpture that I personally have built and cursed myself while I was doing it. And like, why are you doing this again? Like, it was very, very painful. It looked simple on the layout. Just a few wires, bend it this way, that way. But no. So halfway through designing this, I really wanted to give up. And I'm like, this doesn't make any sense. Like, you are an electrical engineer. You are supposed to be designing circuit boards. Why are you doing this? But if you have the end goal in sight, in mind, I think it helps. But I think the end turned out pretty well. It's a tiny snake game thing that I had made where you can play. There are these, the LEDs light up and you chase basically a fruit with the snake made of an LED. On old Nokia phones, I don't even know if you know Nokia phones. Yeah, that snake came. Also a little bit of background, the wooden handle came out of an old measuring cup. And I had 4 of these, and I started the series called Handle with Care, where I would use these handles to make sculptures on top. So I've made a couple of these that are also at the booth. But also being able to use 3D printing and wood and brass together. This is what I was saying, that brass really works well with wood. Same color temperatures. Yeah. Or you probably can just make templates that are not schematics. It could be purely for structural purposes. I made this in Adobe Illustrator. You can use CorelDRAW or other CAD software that allows you to make vector graphics. And so the idea being you just draw things at scale. That is important. At scale, even the width of the lines here is 0.8 mm, so that allows me to measure things properly. Take it to a cardboard or a piece of paper and solder away. And this, although it's not a circuit, it provides a structural value to your actual sculpture. So, during Christmas, I made a Star Wars-inspired bedside alarm clock that basically has a tiny little display, a few LEDs, and the brass wings. Again, the brass wings don't provide any real value apart from circuit. So you can do that. The other thing I want to talk about now is fixtures. So this is all good if you're taping it down to a piece of paper. But what about if you wanted to hold things together and solder them? So I often use breadboards to keep the distance. If anybody has used breadboards, they will know that they are all spaced at 0.1 inch apart. So as long as you're keeping your sculptures when designing with 0.1 inch, you can always use breadboards or PCBs as makeshift jigs. Again, same idea, you use a paper template and these makeshift jigs to solder things together to make something like this. Or another example here that I'm using a different Adafruit circuit board to make a sculpture. Again, you'll see the template at the bottom using a makeshift, like a socket, so that it holds the brass wires in place as I solder. I also use what is called as engineer's square, which is basically a piece of heavy steel block that is exactly at 90 degrees. So if you wanted to make like a boxy thing or something that is right angled to each other, you can use one of those makeshift blocks to help you solder them as like a square angle.
How do you hold it up?
I took a picture after I had assembled. I usually just tape it.
Oh.
Tape the wire to the block so that it holds its position, and then you solder it. Again, heavy use of flux. The other tip I would give is using paper helps when you're applying flux, because the paper will absorb the excess amount of flux, and so only the flux remains on the brass where you want to solder. But yeah, that turned into this. This is also a sculpture that I wanted to make to appear as if it had a face and a body and a neck. And so it's nothing but a thermometer. All it does, on the top you'll see that there's like a tiny little sensor that measures temperature and displays it. It also is connected to the internet, so you can read what the temperature is in your room remotely, or monitor the temperature of a basement over the course of a year, or anything that you want. But the idea again being here that the sculpture is telling you the temperature rather than you reading the temperature. That's why making these sculptures is so much fun. 3D printed jigs. If I'm assembling lots of lights or things that are repetitive, I like to use 3D printed jigs that help me place these lights in one spot. These are also all open source. I made those using Fusion 360 software. And if you know about thingiverse.com, it's an online database where people share their 3D CAD files, so you can make your own. So there are a few people who actually printed these out and made their own sculptures. So this helps when you can, if you want to make a display. The snake cave that I showed you earlier used one of these 3D printed jigs. This was my first attempt at making one, which is just simple square 8x8 LED matrix that will display things. This was another attempt at making a hexagonal shaped display. But I often reuse these jigs to make something completely different. So this, on the left, you'll see it's basically a sound monitor. It will tell you how loud the surrounding is. And this is nothing but a glorified flashlight. It does nothing more than just turning a bunch of LEDs on. So yeah, you can use 3D printed jigs in more innovative ways. I have been working on using PLA, not PLA, but PVA, which dissolves in water. So imagine if you made a jig that you solder things together and put inside water, and the jig melts away, and you're left with the sculpture. So that is something that I've been working on with not so good results. But maybe in the next Maker Faire, I'll be able to show something like that. So yeah, cutting and bending. So this is where I actually photographed a bunch of things so I can show you the steps. I wanted to have video, but videos and presentations for me have never worked well. So all I have for you are static images. So what I start with is a brass wire and a graphite pencil. Instead of using a marker or a pen or a scratcher, I use a graphite pencil because then I can just rub off the marking. But it stays long enough for me to be able to cut. So I'm using those fancy retaining flush cutters, and you'll see why. That wire still stays with the flush cutter. Otherwise, it will go flying off, and you will never find it. Also, having said that, the cut, when you cut This is no big deal, but if you look closely, the cut are not the same. One is flush, and while the other is like a wedge at an angle. So if you are building sculptures that require 90-degree like, proper contact, then you may want to make sure that which end of the wire you're using. Next step, bending. And as I said, I use the templates on a piece of paper to measure what the angle is, and I'll go back and forth until the angle is right. In this case, it's actually right, but it can be an obtuse angle, an acute angle, or some weird organic shape. People often ask, like, how are you able to bend it with such accuracy? It's actually very, very easy. You can just bend the brass and see what the angle is, match it against the template, and go from there. There's no rocket science to this. This is very easy. People have been doing this for centuries. So, all right. After you have created this shape, the next step is soldering. And soldering again is one of the easier steps. All you do is tape it down to a piece of paper with, I use a masking tape, or there's a word for this tape.
Scotch tape.
Scotch tape. So yeah, use Scotch tape so it doesn't leave behind any nasty adhesive residues. You apply solder, flux. I myself forgot about flux. Flux first. And then you apply solder and heat. So in this case, I actually don't need to apply flux because I have the wire coming in from one end, heat from the other, so it all melts nicely. But if I were to make a sculpture that is intricate and I'm holding the brass wire with one hand and applying heat with the other, then in that case I will need to apply flux first. And that's pretty much it. You have a solder joint, but you also have the residues and some tarnishing because the brass is oxidizing as you are applying heat. One quick way to clean this up is to use a steel wool, like a 000 or 444 number steel wool. And just give it a little scrub, and you end up with a really clean solder joint. This step usually people miss, and it's not important. But if you're using flux that is heavy in acid, it will slowly eat away the metal. So it's always good to scrub off the burned flux or any other residue and then wash it if you can. So yeah, that's pretty much it as when it comes to making sculptures. So how do you go about powering the sculptures? There are many, many ways. My favorite way is to use a USB, micro USB. Sometimes the USB is directly on the circuit board that I'm using, or I use something called as a brick output, where there's a tiny little circuit board that has a USB connector on it, and I can derive power from the USB port. USBs are common now, like cell phone chargers and wall adapters, so you can find the source very easily, as long as you have the right connector. The second way is I just simply use wires. A lot of sculptures I make, you can just put it on a piece of breadboard and power it on a breadboard, or solder wires directly to it. The third and most common way is to use batteries. I often use lithium polymer batteries because they're easy to charge. They hold a lot of power, and they are small. I could also use traditional alkaline batteries or rechargeable batteries, but they are more bulky. But you have to be careful because if you scratch them, dent them, they will catch fire. And that is one reason why you are not allowed to have big computers or batteries in your checked luggage. Because if they are damaged, they can catch fire, and then bad things happen after fire happens. So yeah, using battery, and the most recent sculpture that I made was using solar energy. So the actual solar cells came out of a old calculator. And these are extremely inefficient, and so nobody makes them. So you can find them at surplus stores or old calculators. And so this is a beam-inspired circuit sculpture, which looks like a satellite, or maybe a dragonfly if you squint your eye. But the idea being it recharges all day. As soon as it's dark, it automatically recognizes it's dark because the solar panels are not making any energy, and it starts humming. It's a term described to show that the LED is pum, pum, basically flashes. And it's like a night light that flashes. But this is a self-sustaining sculpture. All it needs is solar energy or ambient light in the room, and that's enough. So yeah, that's about powering the sculptures. This tip, what I mentioned earlier, how do you convert a wire to a rod? Because rods are pretty expensive. They will cost around, I think, $2 or $3 per 5 feet. And you can buy like 30 or 40 feet of these wires for $10. But there's an extra step involved where you have to actually turn these bent wires into rods. And this is a technique that has been used for a long time, but I was recently introduced to, is you use a drill to hold a piece of wire and you spin it. You hold the piece of wire from the other end and it actually twists into a straight rod, which is fascinating when you actually do it. I have a video on my Twitter and Instagram account, but since videos don't work very well, I just took some screenshots. You cut the wire like a feet or two, you make a loop, and then you put this loop inside the drill chuck, and then you hold the other end with a piece of like a plier, and you basically twist it. And you don't over twist because you will know what happens when you over twist, it will just break. But there's just the right amount of tension that you apply and you twist it that it turns this the wire into a rod. Then that you can bend it again and use in sculptures. Additional thoughts. You can build non-circuit sculptures out of brass. You don't always have to use electronics. So I tried to make a robot chassis using brass. This has been, again, used for many decades by old hobbyists who would use that to make trains, model trains, or ships, or airplanes, like model airplanes. And so, again, not new, but I was just trying to see if I can solder a chassis together, which is also square. I also combined the idea of using multiple circuit boards, and instead of using wire to connect them together, using brass. So the end result is something like this that has a small face and a tail. Have you heard of the Japanese cat called Nyan cat, which shoots rainbows out of its butt or a tail? No. It was an internet phenomenon when it happened, and so I tried making something like that using a robot. I called it Xenyan because it uses a particle dev board called xenon, and it's a Nyan cat, so Xenyan. So this to you is like, oh yeah, 4 wheels, a tail, and like, what does it actually do? So what I did was I used it to paint with light. So if you take long exposure photos of something that is blinking, you will see a pattern emerge. You can't see that with your own eyes, but if you take a long exposure photo of like 30 seconds or 10 seconds, then it actually shows up as an image. And so you can use this to draw text, graphics. People often photographers use this technique with like a wand to draw in air, and I tried doing that with a tiny robot. So that's one thing you could do. You could also use brass in combination with other materials like wood or PCBs, where the brass is not your central element. It just is used as an interconnect. So this is like a bedside clock that I use made out of tubes called Numitron tubes, which are basically like your light bulbs, but they display digits. So in this, you don't even see brass, but there is brass underneath it, which acts like a support and as an interconnect. By the way, none of these sculptures will pass FCC or any kind of certifications. So these are not designed to be as real world products, because every brass wire that you're running is acting like an antenna, and it's like radiating noise. So you probably don't want to mass produce this and sell it because you will fail. Further resources. When I started making this, Hackaday ran a contest about building circuits back in December, and there were like hundreds of entries. People were building these amazing sculptures and a completely different take on what a sculpture should look like. The winning entry was a bird and the nest. A lot of the components over there are purely for aesthetic value, but the circuit actually is embedded in there in that nest. So that was a pretty cool way of imagining or reimagining what circuit sculpture should or be. Then there is an entire computer over here that somebody made, purely based on like freeform software. One of my favorite circuit builders is Yuri. I forget which country he lives in, somewhere exotic Europe. But he made this amazing blooming lily sculpture on Valentine's Day for his wife. And it's a kinetic sculpture. Again, the pictures are not doing justice. So this is what the description goes. If you stroke the stem of the sculpture, it blooms. And it blooms into different colors. And it's pretty fascinating. So you should definitely check his work out too. I think that's it. I'm open to questions. I make other things that are not circuit sculptures. They're like 3D printed objects, parts. But today I was here to talk about making sculptures and how you can make them.
Any questions?
Yes.
More.
Or
Yes.
Oh, okay.
Two questions real quick. One, you said you hold the brass with your hand while you're soldering. Doesn't that get hot?
It does.
And then?
And you learn.
Okay.
You learn not to hold it too close.
And, sorry, go.
But I've burned my fingers, and somehow, just like you develop, what's the word? Calluses when you're
Yeah.
playing guitar. Your human body is amazing. It adapts to heat, and you're able to hold those with more and more ease. But yes, you hold it at a distance, and then I cut off the brass, which is like this. But yes.
Okay, cool. And the other one was, how do you travel with these?
This was my first time traveling. It's basically a poop show because I just like foam everywhere, and I've taped it down to a box, and they all survived. So this might be the only time I bring them out.
Somebody sent you a tweet about.
Oh yes, DigiKey. People from DigiKey said that they have these pelican cases with you can cut out the structure of your sculpture and then fill it in.
So we see folks do that where you get the pelican case and use a laser cutter.
Oh.
Basically cut out the space, the negative, so it fits perfectly. So it has the top and the bottom, so it
And TSA doesn't say anything?
Somehow, yeah, my sculptures came in like cardboard tubes that didn't look like electronics. They were chill. I have gotten into trouble previously, but somehow lately they just let me.
Scanners are better.
Yeah, the scanners are better.
Any other questions?
Yes, sir.
Where is the particle?
Where is the particle booth? Particle booth is number 3 and 4 right at the entrance. It's next to Microsoft, opposite of Prusa printers.
Just that way.
That's easier, yeah. That way. Oh man.
No, so you don't walk out of the atrium and you walk right into the booth. So if you make a left at the atrium, you're there.
What zone?
I'm sorry?
What zone?
A zone.
Zone 2.
And so you'll get to see all the sculptures. I mostly kept them turned off. But yes, if you are there and you want to see them in action, I can definitely give a demo. We also have particle products out there which I use to make these sculptures. So you can also take a look at those. We have an amazing space team booth where you can play games with each other.
When you mentioned about the parts, where did you say we can get the parts if we were to want to start something like this?
A lot of websites, you can start with Amazon. That will be the most expensive. Digikey.com is one website that sells electronics. It's based out of Minnesota, which is where I live. And so, yeah, or Arrow Electronics. But if you want to buy like dev kits or tiny computers.
Sort of like a kit, kind of like,
Yeah.
so at least I have everything that's available all together. We're able to just grab the soldering and put it together, follow what you're saying.
But yeah, sadly there are no kits available to do freeform soldering. You can buy the parts individually and assemble them together. But as far as electronics go, you can buy electronic kits that are not freeform from Adafruit or SparkFun or Seed Studio. I'm a big fan of Adafruit and SparkFun because they're all open source. So they make their design files completely free available, just like Particle. All our circuit boards are open source. So if you wanted to make your own or learn how we make ours, you can do so.
What's the 2-2 entry in this matrix that right behind the Q? Questions.
Right behind the Q, the 3D printed with the colored knobs. Oh, that, I usually take close-up pictures. If you see, there are a lot of pictures that are zoomed in. And I figured that if I use colored light to light the scene up, the pictures come out nice. So I made a tiny little, you can see the lights there. Basically, tiny little light box that I can change the red, green, and blue values to make different colors and use those to take pictures with. That's it. Actually the most used thing that I've ever made, apart from the bedside clock. But yeah, the mesh that you see on top is inspired by Islamic arts. If you go to mosques, they'll have an intricate geometric art mesh. And I drew that in Adobe Illustrator and printed it and used that instead of just plain enclosure. There's a lot you can experiment with. That's a 3-wheel robot that goes in any direction, doesn't need to turn. So yeah, there's a lot of fun stuff that you can do. These 2 robots are actually open source project, not my design. But since they have their design files available, I can simply download them and print them or modify them. Maybe part 2 could be that you hang out at our booth and see these sculptures in person. That's it then. Thank you.